Up to you, Febe.
Okay, thank you very much for you, Mark, and good morning for everybody who is attending this webinars and this fourth presentation we are going to have as part of the technical trainings, and we hope at the end that more people, members of our project, will accompany this presentation. You had very few interesting talks before. One at the beginning given by Mark Gubars in relation with the organization and also the structure, the technical structure that we are following inside our project. And then you had the very two interesting talks about free and open source software with Professor Frédéric Questier. I was attending the last one, and it was very interested. But I reviewed the first one on the Moodle platform, and precisely I'm advising you or remembering all of you that you can access the Moodle platform of the network, and you can find all the information there. And it's easier for the team members to go there because of the bandwidth and also the network characteristic we have here in Cuba to access all the presentation and the information. And okay, I will also have two talks, one today, and the next one will be next week on Monday. I'm only have to give a second advice because the one of Monday will be an hour earlier. It will not be at 10 o'clock in the morning. It will be at 9 o'clock. And even when we are going to make some advisement over the Telegram group, it will be good that you know from now that it will be an hour earlier. And also, Mark did some change of the time in the schedule that you can review over the Google Doc. But it is good to remind everybody that the session of the next Monday will be at 9 o'clock and not at 10 o'clock as this one. Okay, based in the information you received before from Frédéric Questier about free and open source software, I think that it is time to give some knowledge and ideas about the principles for cooperation and collaboration in software development. And as you see in the slides, it will have two parts, as I told you, one today and one next Monday. And at the end of the second talk, we can have questions and comments and suggestions about any of those parts. It doesn't matter if it is something about the things we are going to talk today, or if they are going to be about the aspects we are going to talk next Monday. And today, I want to share with you some ideas concerning software engineering evolution, because it is something that you really know that it's not the same these disciplines since its beginning in the last century and the current context we have in software development. Then we will dedicate a few minutes to understand what is and what is not really cooperation and collaboration in software development, to pass a little bit later to the areas for cooperation and collaboration in software engineering. And I want to finish this talk of today giving some keys for cooperation and collaboration in software engineering. As you see, it will not be really a long and huge presentation. I hope so, to be only talking around 40 minutes or 45 maybe. And let's go deep into the content. I want to start using two quotes from two very well-known researchers and practitioners in software engineering, based in the information that most of the team members we have in a Linux project are computer scientists and computers engineers. Maybe you have a very good information about both authors. I'm talking about Roger Pressman and Bruce Matzin. That is a very well-known book of software engineering that regularly it is used in all the computer science and software engineering programs all over the world. And I want to stay with these two main ideas because those ideas are really interesting. The first one, as you see, say that we all want to build software that makes things better, avoiding the bad things that lurk in the shadow of failed efforts. And to succeed, we need discipline when software is designed and built. We need an engineering approach. And I invite you to put this quote in the contrary direction, because as you see, the most important thing in software engineering is precisely the approach. It's something that when you talk with software engineering practitioners, you can identify that most of them think that software engineering it's only modeling and giving some orientation and task to the team members until the product is ready, and they don't understand very well that the whole thing in software engineering remains in the approach you have in your mind and the way you implement this approach. And of course, it's the approach, the way you can avoid bad things, and the way you can succeed in the software engineering. And for this reason, this is a very simple, but at the same time important idea for software engineering. And most of the time, practitioners don't have this feeling, don't understand software engineering this way. And the second quote is precisely that software engineering has evolved from a obscure idea practiced by a relatively small number of zealots to legitimate engineering discipline, and that today it is recognized as a subject worthy of serious research, conscientious study, and tumultuous debate. It's also a very good quote from Pressman and Maxine book, because as you know, regularly in technological disciplines, it is usual that they start being practiced only by a few people, most of the time people that are locked down in a laboratory, people that don't have too much communication with the outsiders. And then these disciplines start being recognized by the rest of the community, and at the same time this discipline will win area of knowledge and will connect with another disciplines around it. And it happened with software engineering. If we go to the beginning of software engineering, we will realize that of course it was a very obscure discipline taught only by very weird people that were most of the time misunderstood by the others around them. And only a few decades later was really a topic of interest of all the software developers and all the the software companies and industry in general. And nowadays, we can say that software engineering is precisely the main backbone of the software development. And if you can be a very good programmer, but if you don't have a very good knowledge about software engineering, it will be sometimes a lot of problems and issues you will face programming your software. Or the contrary, it is not possible to be a very good software engineer if you don't have a very good knowledge of programming. Those are two fields of computer science that nowadays has a very tight relation. Taking these quotes as the starting point of this presentation, I want to go them to a very simple definition of software engineering, but it doesn't mean that this simplicity decrease the importance of what this definition says. First of all, software engineering, we need to understand that it is the application of a systematic, disciplined, and quantifiable approach to three main parts of the process of software development. Precisely the development of the software, the operation of this software, and the maintenance of this software. That is a very important idea of software engineering, because most of the time, practitioners that build software only dedicate to the development of a software, but don't give the same attention and the same importance to the operation or the maintenance of this software. And it is very bad for software engineering. And at the same time, it is the left part of this slide that you need to understand that the approach to face software development need to have the three characteristics at the same time and during the whole process. It is this approach needs to be systematic, disciplined, and quantifiable, because it is not only important that you can do the same activities all over the time, it is important also that you can teach the practitioners how to do it, and most important, the newcomers need to learn and to understand what systematic and discipline means. And also you need to have information, statistics from the execution of this process in order to be able to improve the same process, the next iterations or the next steps, you will do the same activities. It is a continuous improvement process where you need to really be systematic, disciplined, and quantifiable to really be able to impact development, operation, and maintenance. As you can see, it is not really a definition of the last years or decades. As you can see, is a definition of the last century. But as I told you, it is a very simple definition, but this definition declares exactly which are the 6 main aspects of software engineering. Then take account, we can say that as in many technological aspects, of course, a definition of 1993, when you look at it from 2021, you will see that it has some changes, okay? It is something that we can expect. And at the same time, the 21st century software engineering philosophy, or the definition of software engineer during this century, increase some of the process aspects we need to target. For example, in the previous definition, you only talk about deployment, you only talk about development, and you only talk about maintenance. But nowadays, we also include in software engineering things and knowledge about analysis, modeling, validation and verification, evolution of the software, something that is really important, and also the approach itself. Because some years ago, we can say some decades ago, the software engineering practitioners didn't give too much attention to the approach itself. We, when I mean we, if the computer science people that work in software development, we created some very well-known approaches and also very well-known engineering methods to follow software engineering. But the time gave us enough information to realize that we need to continuously change and update the approach. Therefore, also the approach itself was included in the area of research of software engineering. But of course, it is not the same the software engineer of the 21st century than the software engineering of the last century. If you give a look to the left image I put in this slide, and the year 1960, that was precisely the moment where Fritz Bauer defined the first time what software engineering was. You will say and you will notice that, of course, the main characteristics of software engineer were very different to the characteristics we are facing nowadays. First of all, we can talk about the organization of the software development process. There was a local organization, and this local organization was only at the institutional headquarters of the main companies or the main groups that were developing software last century. At the same time, these first characteristics promote the second one. The second one characteristic is precisely that the project teams weren't very big, was a small and medium project teams. As I told you in the quote of Roger Pressman and Bruce McSinn, it was only a few of fanatics who were developing software, and only a few people understand really how to build software. And of course, if they were at institutional headquarters, being in small and medium project teams, of course, they can have a face-to-face work. That is, they can see each other at every time, they can talk with everybody. And of course, they have to use centralized tools for software engineering. And also, they can establish a network of personalized communications to build software. It was really very easy, if we can say this way, in comparison with the way we work nowadays, to build software at that moment. Easy in the methods we used for software development. Not easy because of the system we developed, but easy in the way to communicate, interact, and really manage software engineering. And at the same time, the concentration of the systems we were developing at that moment was precisely the programs to let the mainframes operate. And therefore, we didn't have too much preoccupations and worries about another domains and kind of software, because we need, first of all, to put mainframes functioning in the places where they have it. But what happened when we move a few decades later and we arrive to the 21st century? When we do that, we realized that these conditions changed completely, Because first of all, the distribution of the practitioners of software engineering changed completely. We moved from being localized in a headquarters, in a lab, to build software, to be distributed. And most of the time, we are distributed in different locations, not even in the same country. Most of the time, we are people being part of the same project, but living in different countries, in different continents. And for that reason, we have a very huge distribution all over the world. Precisely that produce a new characteristics of the software engineering nowadays, and is that we move from a small and medium projects to large project teams. I used a very good picture of the ending of the All in First seminar we did in 2018, and maybe some of you can find in the picture, you can give a further look to the picture. I'm sure that you will find yourself, some of you will find yourself there in the picture. But it's only to give an idea of the project teams we have nowadays. For example, based in the international information socialized by the international organizations about software computing, are saying that usually the project teams are between 50 and 500 of team members. That is a very large project teams. And if we move from the international users and developers software communities, we will know that this amount of practitioners will increase drastically, and we can have communities of thousands and maybe millions of people all around the world working in different projects at the same time. Also, there is a new characteristic for exchanging and interacting between the practitioners of software engineering. Okay, we move from face-to-face work to telework using the telecommunications technologies we have nowadays. Because of course, if we are distributed all over the world, and if we are a large team, we need to use a new approach, and we need to use new methods for communicating between everybody in the project. Okay, it is something that this COVID-19 pandemic put over the table in a huge manner. Okay, and we realized in the last 2 years that it is really important to develop in our team members and in our software professionals a very good skills for teleworking and telecommunications. And precisely, telework and telecommunications is not possible if we keep using the same tools that we use in the last century. Therefore, we moved from an internet-based tools, and at the same time, we are using not only tools that it is specific for our field of work, we also use a lot of tools that it is for regular communication, and it not only technological tools that we have been using, for example, for modeling, coding, and also projecting the way we organize and the way we do our projects. We also are using nowadays a lot of tools for mainly communicating and also for sharing and cooperate in the executions of all the tasks we do inside our projects. And precisely this internet-based tools and also the teleworking and telecommunication make possible a new characteristics in the software engineering of this century. And we arrive to a community-based communication. It's something that Professor Frédéric Questier talked a lot in the last two talks about free and open source software, and you realized, and of course, I'm sure that most of you also have your own experiences being part of a community and participating in a large community development, not only for free and open source software, also for another kind of communities, being users or being developers of software. But it is really important to understand that the philosophy of the current software engineering is based in a community approach for communications. It is not longer reliable to use personal communication, personal networks. You need to be really connected with international or at least national or regional communities of developers and end users to let you be able to understand the domain of the software you are working on, and at the same time to be able to give to this community a very good and effective product. Okay? And as one of the last main characteristics of 21st century software engineering, we can say that we also move from being software practitioners that use only solutions that we build by ourselves in a laboratory to share a lot of solutions, and also to put these solutions with parts that are nowadays in the cloud, or also we are using third-party solutions in our software development. Of course, based on the information given in the previous talk, you can understand that the main characteristics, it's we moved from very good localized solutions to a distributed systems philosophy in software development. It is precisely because there were an increment of the complexity of the software, and also it was an increment of the complexity of the technologies we use for software development. Therefore, we cannot afford all the time to have all the technologies in the same place, and we are able nowadays to use technologies that is owned by another institutions or organizations and use those technologies as services, and we can also have another solutions shared by another software developers all around the world. And what I want to realize is precisely that when you make a comparison between the 20th and the 21st centuries software engineering looks, you will find that in those 61 years of evolution, the change was drastically, and we cannot keep doing the software engineering the same way that we did it 60 years later. Okay, we have to move to a new approach, and we need, of course, to update our understanding of software engineering. Because if we keep in the philosophy of software engineering of the 60s of last century, we will fail in the way of developing software. Taking all these characteristics in mind, we can, for example, give a look to this simulation of the software market growth rate by region, did it by Mordor Intelligence. And this simulation is still until 2024. We are in 2021. We are exactly in the middle of this simulation, and even taking into account that they erased completely Greenland and Russia in this simulation, and you know that that nowadays Russia has a very huge impact in software development. But okay, putting that ahead, and okay, and taking that apart, we can look in this simulation that exactly we still have a very high regional growth rates in Asia, in Europe, and in North America. And precisely, we are nowadays working with two enterprises, one of Europe and one of India. And it is precisely because those areas, those continents in the world, has a large information and knowledge to share, and they have a lot of things to share with the rest of the world to really improve the way we do the software development actually. Okay? And for that reason, it's only this picture is only to show you that this situation we are facing nowadays will of course impact constantly the way we do software engineering, and we can expect in the next decades some other changes and an improvement of the way we do software engineering. And when I say improvement, I mean some increment of the interconnections and the exchange of information and the exchange of solutions we are going to use in software development. But we can go now to the ways we understand the cooperation and collaboration in software development. When you asked someone what she or he understands about cooperation and collaboration in software development, they only give you these three main ideas. They say, okay, cooperation and collaboration in software development, it's related with the sharing of the ideas about the software. It's something that has to be with the teamwork we need to have inside our project, and also the close links we need to have between the team members' task. And if you give a look to these three characteristics, it's not only needed in the free and open source software community, it's also something that you need in any kind of software project you have you are being part of. Okay, and precisely cooperation and collaboration has some other ideas we need to understand very well to avoid misunderstandings and to avoid miscomprehension we can have of this of what cooperation and collaboration is. Okay, and I did this graphic to show you that cooperation and collaboration in software engineering in the last 35 years split it in three different main branches of the conception of cooperation and collaboration in software engineering. And nowadays you can find three ways of talk about cooperation and collaboration in software engineering. The first one is what it's known as collaborative software engineering or development. The second one is known as distributed software engineering and development. And the last one is known as global software engineering and development. And I put it precisely from the left to the right of the slide to show you the order in which each single understanding of cooperation and collaborations raised on time. Okay? The first way we understand cooperation and collaboration in software development was precisely what we called collaborative software engineering or development. And this approach has four main aspects to look at it. First of all, it's based on a shared software comprehension and understanding. Secondly, it is based on a distributed and decentralized decision-making process. Also, the project management approach is based on a community philosophy and not on a boss and employee relationship. It's more a community where everybody can give an opinion, and everybody can share their thoughts and function as a real community. And the last one of the characteristics of the collaborative software engineering development approach is that that was the first time for software practitioners where they introduce the agile and hybrid methods for software development. Because until that moment, we are stuck only on the prescriptive approach for software engineering. We want to know everything in advance, and life demonstrated us that it is not possible all the time, and sometimes we need to use another approach to really do the software development. In time, the second understanding of cooperation and collaboration in software development was the distributed software engineering. It started when the technology started to change and when we started to do more complex systems. And at that time, we needed to move to a new way of doing software engineering. Because precisely, as you can see, the projects was for the first time geographically distributed. At the same time, we started facing projects of different sizes. And of course, it wasn't only project for small, complex things. We start doing a more complex daily and more complex problems. We start trying to solve very complex issues in society. And for that reason, we start to understand that we need to share resources for all our team members, and also to give all the team members access to those resources. Because if we have distributed system, we need, of course, to give access to the people to be able to really work with the things that are in different locations all over the world. And at the same time, we start doing engineering for distributed software, because until that moment, we have all the solution in one server, we have all the solution in the same location, geographically talking, but since that moment, we start having the software divided in parts, okay? And some of these parts don't have to be in the same place. And the last approach, the last understanding for cooperation and collaboration in software development, it's known as global software engineering or global software development. You can find it this way in the literature. And this approach is the most current way we can realize what cooperation and collaboration in software development is. First of all, the projects are globally distributed. That's one of the main characteristics of this approach. The second one, as I told before, large software systems. It is not a small software system. We have nowadays very large software system. Also, the resources have to be available and accessible independently of geographic location, because this large software system use solutions maybe in another continent, and to use solutions from another continent or a service from another continent, they need, of course, to be in connection. They need to be all the time accessible, because otherwise, if one part cannot connect to the other part of the system, it will not possible to really manage the data and to give the results that the users expect to have it. At the same time, this approach need a critical coordination mechanisms, because it is not the same to manage and to handle project teams of 5, 10, 25 people than to manage project teams of 100, 500, 1,000 of team members distributed geographically in different continents and in different countries, with different cultures, with different philosophies of work, with different sociocultural information, with different politics and economical situation in the different areas where they lived. And therefore, this new way of software development needs a change of the coordination mechanisms. And this is called critical coordination mechanisms. And as I told before, this global software engineering is based in the cloud and third-party solutions, and also relies on formal mechanisms as the level of management of the project. We have different levels of software development. We will see it in a while, but it is not the same of the previous cooperation and collaboration, where we have all the people in the same building and we can see each other only giving a short walk from one office to the other or from one laboratory to the other, and we will meet someone really fast. Therefore, we can say that collaborative software engineering is a collaboration in software engineering. Is usually understood as artifact-based or model-based collaboration, where the focus of activity is on the production of new models, the creation of shared meaning around the models, and the elimination of errors and ambiguity within the models. You can see that this approach is mainly concentrated in the analysis and the design of the software. This approach didn't give too much attention to the other aspects of software engineering. This approach concentrates mostly in the analysis and the design of the software. Okay, but it's very good. This approach gave a very important aspect or characteristics to the software engineering approach we are facing nowadays. Each of them gave very good inputs to the current software engineering approach we are having nowadays. In the other hand, distributed software engineering is an approach that refers to planning, designing, building, testing, and managing software with decentralized teams located across different physical workspaces. This is, as you see, something that this software engineering approach give a very huge attention, because it is not only for analyzing and designing the software, it's also an approach that introduces the issues related with the planning, the testing, and the managing of the software, taking into account that the kernel characteristics of this approach is that the project team is decentralized and the project teams has different geographically locations. And of course, These teams therefore need to use internet-based collaboration tools and communication platforms to build software. It is not possible for this approach to use tools located only in one place and not accessible for the other team members located in another countries or in another part of the world. Okay? And finally, the global software engineering carried out by teams of knowledge workers located in various parts. It's an idea coming from distributed software engineering, developing commercially viable software for a company, but often centralized software development is moved from home locations to dispersed teams or an external organizations in remote locations. The main target aspect of this software engineering approach is precisely that it is not really important if the software is proprietary or free or who is doing the software, because as Frédéric Westier commented in his talks, excuse me, nowadays the private companies of software development are also encouraging their practitioners to be part of the international software communities, to be able to win information and skills in international and collectively sharing and of information, sharing of solutions, and also to improve the skills of their developers to really be able to tackle the problems they want to solve on their companies. And this is precisely what it is the main aspects of the global software engineering. Okay? But what this cooperation and collaboration understandings have in common? Of course, they have some positive aspects in common, and as usual, as any technology or comprehension for humans, they also have some negative aspects. Talking about what is the same shared but by all these approaches of software engineering is distributed teams, segmentation of the software development, shared resources and tools, open management approaches at the bottom, and decentralized decision-making process. You can see that what is the same in the three understandings of cooperation and collaboration in software development is precisely these 5 characteristics. It doesn't matter if we are talking about the collaborative software engineering, the distributed software engineering, or the global software engineering. In any of these approaches, you will find these 5 characteristics. But at the same time, this cooperation and collaboration understandings is facing a lot of challenges, because it is not possible to have the same understanding at 7 different aspects of the software engineering or that impact the software engineering. First of all, there are a huge amount of challenges at the organizational level. We have also a huge amount of challenges temporarily, okay? Because as we spoke a few minutes ago, we have team members distributed all over the world. And when you are, for example, planning a meeting, it doesn't matter if it is technical or not, where people have to meet synchronously, you will face problems that someone is in the night, someone is in the afternoon, and someone is in the morning, and even someone can be sleeping at that time. Therefore, it's it's give a very hard work for synchronize the time for meeting and the time for working. It is not all the time a bad things, because for example in free and open software communities, when one practitioner release a solution and have been working for a long time of hours, and then decided to release the solution, and then wants to go to sleep for a few hours, at the same time someone that is waking up will start to test in this solution, and therefore you can realize that it is not really bad in the whole look to have different time zones between the team members of the same project. But what it is really challenging is the social cultural aspect in software development. You know that the expertise and the experiences of software developers relies most of the time in the way they socially and culturally interact with among them. Therefore, it is really stressing when you put in the same software team people from Asian culture with the Latin American culture, with the European culture, the North American culture, or the African culture. You will notice that of course this is an international project team, and therefore you will have different social cultural ways of giving a look to what you are doing in the software development aspects. Okay. Also, that implies some differences and challenges in the cognitive and educational aspects, of course, the geographical aspect, and not less important, the political and the economical issues that we need to face when we are having a global or a cooperation collaboration philosophy in software development among practitioners located in different areas and continents of the world. Therefore, we will give a look to these challenges deeper in the talk of next Monday. And I also want to share with you what are nowadays the comprehension that the software scientist community has about the levels of cooperation and collaboration in software development. And it is really important to understand these levels of cooperation and collaboration, because usually in the software engineering philosophy of the last century, we only have the level that is in the basis of this diagram. Okay, we only have the team level, and we can concentrate in the team, and we can manage very well, we can handle very well the issues that faced on a team, because we know each other, we are belonging to the same social cultural environment, we have the same political things, we have the same economic context where we live, and therefore the problems we faced were different to the problems we have nowadays. Because nowadays, some members of this team doesn't have to belong to the same country, and this is precisely the upper level, the top level of this scheme. And therefore, you have in the middle the company level, because of course you can have also large system projects that is the result of the relation among different companies belonging to different countries and having different teams, and you need to put all those people together and sharing information, sharing knowledge, and making decisions that will lead the software development to succeed. Okay? But what happened with the previous challenges we described in the previous slide, that precisely when you move from the bottom to the top of this graphic, you will notice that, of course, you will increase the challenges, the organizational, temporal, sociocultural, cognitive, and educational, geographical, political, and economical challenges you face in the software development. It is not really easy to solve the situations you will face in any of these aspects of software development when you work with cooperation and collaboration philosophies. Okay? And then I will give you the opportunity to give a further reading to some of the challenges in each of these levels. You have there some challenges on the team level, then you will have some challenges on the company level, and I used a different color, in this case red, to tell you that these challenges in red are coming from the team level, that move also to be part of the challenges you have to face in the company level. And the same I did it in the country level. Some of the challenges that appear in the team and in company level, you will have it also at the country level. If we give a more broader look to these levels of cooperation and collaboration, you will have this understanding of the levels. We can have a group of critical challenges we need to face when we do cooperation and collaboration in software development. And also, we will have a wrapping challenges. And we can say that at least we need to concentrate in the critical challenges to really manage cooperation and collaboration in software engineering. For that reason, if you give a deeper look to the critical challenges, you need to at least be able to manage communication on the team. You need to be able to do knowledge sharing and transfer. You need to concentrate in coordination of the team. You need to concentrate in linguistic issues. That's the reason why we are given English training, because usually the communication language we use in software development or for software engineering in general is precisely English. We need to concentrate also in project and process management. It's something really important. Also in the tool management, in the software architecture, and also the hardware configuration. There are a lot of examples all over the world where you give attention to the 6 first critical challenges, and if you don't give attention to the software architecture and also the hardware configuration of the different devices you have distributed all over the world, that will put some technical issues that will lead to errors and to misunderstanding and to a lot of troubles inside the project execution. Okay, you can use also this graphic to understand that you can leave the wrapping challenges for a later moment of the project. And if you are going to have a collaboration and cooperation team, you need to focus on the 8 critical challenges I'm showing you in this graphic. Okay, and I want to finish with the areas for cooperation and collaboration in software engineering, because at the beginning of the 60 years of last century, we only think that the collaboration and cooperation was only needed for modeling of the software, as I told you, for analysis and design of the software. And we realized later that it is also important, cooperation and collaboration, in the process and also with the tools we use for software engineering nowadays. And as you see in the process, we need to have a very shared, the same comprehension about the business model, the approaches we are going to follow, the methods and the methodologies. In the modeling, we need to share conceptions, patterns, architectures, and designs. And in the tools, we need to share and to have the and
Faber,
understandings
we lost.
about development, storage, verification and validation, and also about the releasing of the products we are having inside the.
Boba, I'm losing the
Yes.
voice. I don't know if it's maybe the sign. I don't know what's happening.
Yes, I think
Faber,
Faber
I do
is
this.
lost. He has to. You're back, Faber? No, he's out. He's coming back. We wait 2 minutes. Faber? Faber is back, but I don't. Your voice is off, Faber. We don't hear you. Faber? The last two slides were without comments. No. Oops. Faber, you have problems with the connection? No, I don't. We don't hear you. And we missed the last two slides. That's all. I put the slides there about.
Yeah. Oh,
No,
but I
that's.
hear him.
I wanted to put the slides on it, but Febe, yes, I think he has to log out and log in again. That's the best way. I try to put the slide on myself here, and I think he talked about those 4 areas of cooperation, and also about this. I don't know. He will explain more about it, and about these keys for cooperation and collaboration. And I think it's there. Decide the approach and keep it all the way. Communicate as much as you can by different ways as possible. Share your thoughts and speak your mind all the time. Do not use your own tools, but the same ones that your colleagues can access. Cooperate in all the software product aspects during the whole procedure, and by the same tools as everybody.
Can you hear me?
Now we can hear you.
Okay, let's me share my screen again to.
Okay, I will close my screen then. I will.
Okay.
Stop,
okay.
and I will leave it to you again. I think we missed the 3 last slides.
Can you see it?
Nothing at the moment.
I can see it.
You can see it. That's the most important. I don't see it. I think we had that problem before. In Cuba, it's visible.
Okay. When it's only the last slides. I was sharing with attendants some keys in a sort of summary of the main things I have been talking. Okay, therefore it is not really necessary to read all the keys for cooperation. You can give a further look to this slide, but you can see that sharing and cooperating is really important. Okay? And I wanted to give some announcements of the things we are going to talk about next Monday, and it is about. We will talk about the levels of cooperation, as I did. I will go deeper at the team level. I will go deeper at the company level, and I deeper at the country level, and I will also give some information about the tools for cooperation and collaboration for software development. Okay, and at the same time, I want to make some relationships between the principles for software in computer science movement and fields, because we had 2 talks before about free and libre open source software, which is very good related with what we are taking today about cooperation and collaboration. And also we will have some ops, which is also another movement and another approach or philosophy to do software engineering or software development in general, and it's really good related with the things I'm talking about. Therefore, I want to also make some relationships with the that the team members had and will have in the future. Okay, and I will give also some ideas of the future work inside our project that we need to do to really implement cooperation and collaboration in software engineering. Okay, sadly or fortunately, the technical issues were only at the end of the presentation, and most of the time I was online and available for all of you. I will stop to Mark take the lead again of this meeting. Thank you very much to all of you for listening. All things shared.
I will finish. I will stop the streaming now.